Alright, 4.2. We're going to practice simplifying square roots here. Some basic things that you need to know is that if you have two things multiplied together inside the square root, you could separate it as one square root, and the same thing is true about dividing. If you have a square root over, or a square root with some number over a number, you could separate it as two separate square roots. So just something to know that's going to be useful. Now let's talk about, first of all, let's just talk about simplifying square roots. This is review. You should have done this before. What you're looking for is you're looking for a perfect square that goes into 50, and that's easily 25, right? And so you could write this as 25 times 2. Well, if you could write it as 25 times 2, you could write it as 25 underneath the square root as 2 underneath the square root, or square root 25 times square root 2. And you cannot take the square root of 2 without getting some weird decimal. But square root of 25 you can do. And so this equals 5 square root 2, or 5 rad 2. Okay, pretty simple. I just pulled out the biggest perfect square I could find. I want you guys to do the same thing with practice 1. Go ahead and pause the video and give it a shot. Okay, the biggest perfect square I could think of that goes into 180 is 36. So I made this 36 times 5 because that equals 180, which means I could break it into two separate square roots, which means the square root of 36 is 6, and all that's left is the square root of 5, and that can't be simplified. Now, from this step to this step is kind of redundant. I'm just trying to get you to see why you can do this, why you can pull a 6 out the square root. If you can see it, you can go straight from here to here. I want you to see why. All right, let's take a look at example number 2. Okay, remember I said if you got something that's being divided, you can write it as 2 square roots. So let's go ahead and do that. That would mean that this is the same thing as the square root of 1 over the square root of 96. And the square root of 1 is pretty easy. That's just 1. And so now I want to think if there is any perfect squares that go into 96. And it might take you a little bit to see it, but that's all right. I think that I can pull a 16 out of 96. In fact, 16 times 6 is 96, and so I could write this as 1 over the square root of 16 times the square root of 6, which is 1 over 4 square root 6. Okay, so at this point I want to go over something. Technically this is correct, but it's not in the right form. We don't really like leaving square roots in the bottom. It's not really a big deal, it's just that sometimes you might see them change this so that the square root is not in the bottom, and you have to know how to do that. What they're doing is they're not changing its value, but they're changing the way it looks. So the way we change how it looks is we do something called rationalizing the denominator. I'm going to write that for you. It's called rationalizing the denominator. Deal with my handwriting. And you're always just going to multiply it by square root of whatever number is on the bottom over that same number, because this is just equal to 1. Whatever x is, square root of a number over that same square root of a number is going to just equal 1. And in this situation we have a 6, so we're going to multiply this by the square root of 6 over the square root of 6. When we do that, on the top we get 1 times square root of 6 is just square root 6. But on the bottom we get 4, and the square root of 6 times the square root of 6, well, that is just 6. And so we get 4 times just 6, or the square root of 6 over 24. And this is a better answer, or a more proper answer. They're both equivalent, they're both true, it's just that this is a more proper answer. So just be prepared that if you got a square root at the bottom, you may have to rationalize it by multiplying it by that same square root over itself. Alright, why don't you guys try practice number 2, and don't forget to rationalize the denominator. Again, pause the video and give it a try, and then check back when you're ready. Okay, so we could separate this as the square root of 1 over the square root of 9 times 5. Square root of 1 is 1, square root of 9 is 3. Square root of 5 cannot be simplified, so that's just the square root of 5. We can't have square root on the bottom, so we got to rationalize it. And we get a square root of 5 on top. And remember, the square root times another square root that's exactly the same. It just equals whatever's on the inside. So the square root of 5 times square root of 5 is just 5. Real quick, the reason why, think about that. Square root of 5 times the square root of 5, that's like saying the square root of 5 squared. And these are opposite functions, so that's why. Okay, good. Let's go on to the next one. Alright, now we got more than just a 1 on top. That's okay. We can handle this. The first thing I see here is I think that I could reduce. So before I even try and separate this out, I'm just going to see if I can reduce. And I think that I could definitely take a 2 out of each of these. And if I took a 2 out, it would be the square root. 24 divided by 2 is 12, and 98 divided by 2 is 49. Okay. Alright, now I can start separating this out. So on the top, is there a perfect square that goes into 12? Yeah, there is. It's 4, so I'm going to write this as 4 times 3. And on the bottom, I can write this as just the square root of 49. Alright, well, hopefully you see what's happening here. The square root of 4, that's 2. Square root of 3, that does not simplify, so it's just square root of 3. And the square root of 49, that's 7. And so we have simplified this to 2 rad 30, or 2 rad 3 over 7. Alright. Got another problem here for you. Go ahead and give it a try. And unpause the video when you're ready to check your work. Okay. I think most of you could get to this answer, but remember we don't want to have square roots on the bottom. So I rationalize it, and 3 times 7 gives me 21, so it's 5 square root 21 on top, and on the bottom I just get a 2 times 7. 2 times 7 is 14, so there we go. Alright, that was some fun practice problems there. Now, let's talk about what happens if we start adding and subtracting square roots. Something to think about when you're adding and subtracting square roots is you can use the same rules as x's. For example, remember if I had 2x minus 1x, that would just equal 1x, right? Because these are like terms. Well, as long as square roots are like terms, we could do the same thing. Let's do a plus this time. Well, these are like terms as well, and so I can just add the coefficients, and so this would be 5 square root x. Or, you know, we could do something different here. I could do 3 square root 2 minus 1 square root 2, and that would just be 2 square root 2. So we're going to treat square root symbols the same way we treat variables, as long as they are the same square root. Notice here, these are not the same square root, but we can simplify them. So it says simplify the expressions by removing all factors that are perfect squares from inside the radicals, and then combine like terms, just like I can combine like terms here. So let's think about this. Any perfect squares in 32? Well, yeah, there's 16. 16 goes into 32, so this is really like 16 times 2. And any perfect squares in 18? Yep, 9. So I can write this as 4 square root 2 minus 3 square root 2. And 4 minus 3 is just 1 square root 2. So that's all you really need to write there. Okay. Now you've seen that, remember, simplify it, and then you can combine like terms. So I want you to do the same thing here. There's some perfect squares to go in here. Go ahead and pull those out and simplify. Then unpause when you're ready to check your work. Okay, so hopefully you saw that 9 times 7 is 63. 9 is a perfect square. You get a 3. There's already a negative sign out there, so it becomes a negative 3. And 16 times 7 is 112, so you can take the square root of 16 and get 4. You have a negative 3 and a negative 4. That combines to make negative 7, square root 7. Okay. Pretty good. Let's go to the next one. Alright. For this one, it's a good idea to, first of all, we know that we have a square root of 1 on top. So we could easily separate this into two things. The square root of 1 we know is 1, and 1 times 1 times 1 is just 1. So I'm just going to go ahead and put a 1 on top. And then on bottom, we can actually make this one big square root of 21 times 3 times 5. We're allowed to do that. So I want to show you something here. So even though we're multiplying here, I'm not actually going to multiply, because really I'm looking for perfect squares. So I'm going to see this 21 break down. 3 and 5 are prime numbers. They're not going to break down anymore, but 21, I think that's going to break down. So let's do it. It's 7 times 3, and then times 3 times 5. Well, hopefully what you see here is you actually got a perfect square. In fact, if you wanted to, you could write this as 1 over the square root. Let's put the 3 in front, and instead of 3 times 3, I could write it as 3 squared times 7 times 5. And so we do see that there is a perfect square that we can pull out. This perfect square is 3 squared. Well, the square root of 3 squared is just 3, so we could write this as 1 over 3, and 7 times 5 is 35. Now, once again, we got a square root on the bottom. We don't want a square root on the bottom, so we're going to rationalize it. And we get a square root 35 on top. And the square root of 35 times 35 is just 35. And 35 times 3 is 115. No, that's not true. It's 105. I'm sorry, 105. So there we go. We've simplified this out to one simple answer. No, that's a lot of stuff to think about, but what I'm trying to do is I'm trying to find perfect squares that I can take out, and then all I did is rationalize. And feel free to use a calculator while you do this stuff. Okay, try practice 5. And in practice 5, I have a feeling that some things might cancel out if you write this as maybe just one big square root. In fact, when I start you guys off in practice 5, couldn't we write this as 1 times 3 times 12 over 20 times 5 times 2? And I did that because I want to see if you can see some stuff start to cancel out. You could reduce this before you try to simplify it any further. Go ahead and try and do the rest on your own, and again, unpause the video when you're ready to check your work. Okay, well, first thing I did is I saw the 12 and 2 canceled out, so I took a 2 out of both of those, leaving me just a 1 down here and a 6 here. But then I saw that I could take a 6 out of 20, or a 2 out of 20 and 6, so I got a 3 on top and a 10 on bottom. So that gives me a 3 times 3 on top, which is 3 squared. And inside of 10, 10 is really 2 times 5. So I pulled the 2 out and wrote it as 5 squared. This lets me take the square root of 3 squared, which is, oh, I apologize, I made a mistake. That would be 3, because the square root of 3 squared is 3. And so when you go to rationalize it, that would be 3 square root 2 over 10. Alright, I know there's a lot of problems in this video. It's okay, we're almost done. Alright, very similar problem here. Remember, you can combine these square roots, and so that's the first thing I'm going to do. I'm going to write it as a square root of 2 over 5 times 15, or I could actually write it as 5 times 5 times 3. Maybe you see where I'm going with this. This is a perfect square, and so this is really like saying the square root of 2 over 5 square root 3, and now we just have to rationalize it. Multiply it by square root of 3 over square root of 3, and you get the square root of 6 over 5 times 3, which is 15. Okay, so you're just looking for those perfect squares to pull out. That's how you simplify this. Here's another problem. Go ahead and give it a try. Again, unpause the video when you're ready to check your work. Okay, this one's simplified down nicely. I wrote it as 1 square root because I saw that I could take a 3 out of both 3 and 24, leaving me with 1 on top and 8 on the bottom. And 8 times 8 is just 8 squared, and the square root of 1 is just 1, so I just really have the 1 over the square root of 8 squared. Well, that's just 8, so this is just 1 over 8. Simplifies it nicely. Alright, we are almost done. Now let's talk about multiplying square roots. When we multiply square roots like this, what we can do is we can do the same thing we did with binomials, is we can use the box method. So that's how we're going to attack these types of problems. So let's make it into a box. Square root 10, square root 7. Well, this is nice because the square root of 10 times the square root of 10, remember, this is just going to be what's on the inside. This is just 10. And in the same way, the square root of 7 times the square root of 7, that's just 7. So that's nice and easy. Square root of 10 times the square root of 7, that is the square root of 70. And that's the same thing here, it's the square root of 70. So now you're going to have like terms here and like terms here. So 10 plus 7, well, that's 17. Plus, if I was to add these together, you could think of this as 1 square root 70 plus 1 square root 70. So that's like 2 square root 70. 70, it does factor down, but you could factor it down and you would just get, you could do a 35 and a 2, and then you could do a 7 and a 5, but there's no perfect squares inside there. So this is actually as simplified as it can get. There we go. Alright, one last problem for you to try on your own. Go ahead and give that a shot. Why don't you do box method and just simplify it out. Okay, when you box method, I got 14, square root of 84, square root of 84, and 6. And 14 and 6 just makes 20. And I already see a typo here. And I have 2 square root 84s. And what I noticed is that there is a 4 inside of 84. So I broke it down to 4 times 21. And the square root of 4 is 2. So I really have a 2 times 2 on the outside, which means that my final answer should be 20 plus 4 square root 21. Alright guys, I know there was a lot of problems, but I think you guys can do this. I'll see you guys on the next video.